So greetings of the day, dear students. I'm Shilpa, an assistant professor from the Department of Mathematics. So today here I'm presenting the topic called as numerical methods. So in this video, we will have a brief description about what is a transcendental equation and the methods to solve the problem of transcendental equation. So before discussing about what is a transcendental equation, we'll discuss what is the meaning of a root. So root of an equation. So for example, if I have f of x, so if I have only f of x, it's called as a function. And if I have f of x is equal to 0, it's called as a equation. So as of now, we have many methods to find the root of a equation. So before that, functions. We have algebraic function, trigonometric function, exponential function, logarithmic function, and many others. So if I have the representation in the form of f of x is equal to 0, then it's called as a equation. So whenever we have in such a form, here our main intention might be to find the value of x. A small example. If we have x minus 1 equal to 0, then what is the value of x? X is equal to 1. That means if I resubstitute the value of x is equal to 1 in this equation on the left hand side, then I will get 1 minus 1 which is equal to 0. Then this x minus 1 equal to 0 is called as root of an equation. What it is, if x is equal to 1, if I am substituting the value of x is equal to 1 in the given function, then if that function satisfies and if that value is equal to 0, then that value of x is called as root of an equation. So from the school age or from the intermediate or whatever it may be, we have seen how to solve an equations of these forms: algebraic, trigonometric, exponential, logarithmic. But for example, if I have an equation of this type, x into e power x is equal to 0, or x sin x is equal to log x, or x cos x is equal to e power x. If I have such model of problems, then how can I find the solution for these models? So that is our concept called as transcendental equation for numerical methods. Transcendental equation for numerical methods. So these are the examples. So whenever we have more than one function in an equation, then that equation is called as transcendental equation. What it is called? It's called as transcendental equation. So these are the few examples of transcendental equation. So now here in the first, we are going to discuss about the first method called as bisection method. Irrespective of the method, in a numerical method, for finding the solution of an equation, first we need to find the initial roots. Always for any procedure, the first step will be finding initial roots. So what is this meant by initial root? So in order to start a problem, we need to know where does the root lie first. So how can we find the initial roots is the procedure first. So for example, if I have an equation x cube minus 6 x minus 4 equal to 0. First, we are going to assume f of x is equal to x cube minus 6x minus 4. So this is first step. So how to find the initial roots? First we'll start with the 0, f of 0. 0 minus 6 into 0 minus 4. Minus 4 is less than 0. F of 1. 1 minus 6 into 1 minus 4. This is also less than 0. F of 2. 2 cube minus 6 into 2 minus 4. So wherever x is there, that x will be replaced with 2. That will be minus 8 less than 0. Next, f of 3. So you may have a doubt up till where we have to continue this process. Now if you observe, f of 2 and f of 3 are both of opposite signs. So you have to continue until the process, and you have to continue this process until two successive terms of x, their functional value should be of opposite signs. So this is x and this is the functional value. So if you observe, for this value of 2 and 3, the functional values are of opposite signs. So we can stop the process and we can give a conclusion that root lies between 2 and 3. So this is the initial process of irrespective of any method. Okay, so this is the initial process. If it is mentioned in the problem, no need of finding the initial roots. If it is not mentioned, this is the way you have to find the initial roots. Then after finding the initial roots, here we are discussing about the bisection method. Bisection. It's also called as algebraic method. By means what? Dividing into two parts. So similarly, the formula will be x1 equal to a plus b by 2. These are the roots. Or x0 equal to a plus b by 2. So we'll consider the same example. We are finding the solution of x cube minus 6x minus 4 equal to 0. So coming to the procedure here, solution. First, let us assume f of x is equal to x cube minus 6x minus 4. For all the numerical method problems, calculators are mandatory. So do carry your calcs. So we'll find the initial roots. F of 0, just now we have seen how to find the initial roots. F of 1, f of 2 is less than 0 and f of 3 is greater than 0. You may have a doubt. If all the if x values are all are negative, then you have to go to the opposite sign, that is f of minus 1, f of minus 2 and f of minus 3, and check out which successive values of x are of opposite signs. So root lies between 2 and 3. So we are using bisection method. So by bisection method, the formula is what? x0 equal to a plus b by 2. So usually I use this number line for identifying where does the root lie, which helps me to solve the problem easier. So if we observe here 2 is less than 0, we need to observe the x value, not the functional value. We are checking the functional value whether it is positive or negative, but we have to consider only the x value, and 3 is greater than 0. Now my root lies between these two values only. If you are getting a value apart from this interval, then your problem is, the solving of your problem is wrong. So see that your value should lie between the interval 2 and 3 only. So x0, a plus b by 2. So let a equal to 2 and b equal to 3. So x0 equal to 2 plus 3 by 2. The answer is 2.5. Now what we have to do? Again we have to find f of x0. That is f of 2.5. So 2.5 whole cube minus 6 into 2.5 minus 4. This is equal to some, approximately the value is minus 3.375 less than 0. So observe the previous number line. 2 less than 0 and 3 greater than 0. Now again you have 2.5 less than 0. So that 2.5 less than 0, as it is a lesser value, it should come towards the left hand side. Three greater than 0. Now if you observe here, these are the two successive terms. Since f of 2.5 less than 0, root lies between 2.5 and 3. So the next root, next approximation, x1 equal to 2.5 plus 3 by 2. The answer is 2.75. Again you have to find f of x1, that is f of 2.75. So 2.75 whole cube minus 6 into 2.75 minus 4. The answer is approximately equal to 0.2968 greater than 0. Now again we'll draw the number line. Now we can exclude this value. We have to include only these two values on the number line. So 2.5 less than 0 and 3 greater than 0. Now what is this 2.75, is it positive or negative? Positive value. So which side it should be? It should be on the right hand side. So 2.75 greater than 0. Now if you observe, what are the successive terms? 2.5 and the 2.75. Since f of 2.75 is less than 0, a root lies between 2.5 and 2.75. x1 is over. Next, x2. Again the formula 2.5 plus 2.75 by 2. So whenever you are solving a problem in numerical method, see that you are going to consider the value up till 4 decimal of places. So 2.5 plus 2.75 by 2, it is approximately 2.625. So whatever the roots we are finding here, all the values are approximated values. They are not the exact values. So 2.625. Again we will find f of 2.625. So if we observe, when we calculate the value, it is also greater than 0, it is less than 0. We got x2, which is 2.625. We are finding f of 2.625. If we solve the value, we get minus 1.6621, which is less than 0. So now again, if we consider the number line, 2.5 less than 0 and 2.625 less than 0, 2.75 greater than 0. Now where does the root lie? Root lies between these two successive approximations. So root lies between 2.625 and 2.75. So we have to continue this process until two successive approximations are equal. So usually in bisection method, the rate of approximation will be very slow compared with the remaining methods. So next, x3 equal to 2.625 plus 2.75 by 2. So the answer is 2.6875. What are the meaning of approximation? So this x2 and x3 are called as approximations. So we continue the process until these two successive approximations are equal up till at least up till 3 decimal places in bisection. Whereas compared with the remaining numerical methods, we have to go with the 4 decimal places. So this is a small explanation about bisection method. So here continue the process of approximations until two successive approximations are equal up till 3 decimal places. Only in bisection method we get the approximation approximately at x19 and x20 also. So do the problem carefully. The next method that we are going to discuss is about the Newton-Raphson method. So compared to the bisection method, Newton-Raphson method, the convergence of the root will be faster compared with bisection method. So here in this case, step 1 will be the common, that is finding the initial roots. Step 2, the formula is given by xi plus 1 equal to xi minus f of xi by f dash of xi I equal to 1 to so on. So only for finding the initial roots, we check whether it is negative or positive. Whereas for continuing the problem, here it is not required to check whether it is positive or negative. We can directly solve the problem. So for example, f of x is equal to e power x minus 3x. I need to solve this problem by using the Newton-Raphson method. So here already we have the root lies between 0 and 1. So the initial approximation x0 will be 0 plus 1 by 2. Only the initial approximation, first approximation, that is 0.5. And by Newton-Raphson method, the formula is given by xi plus 1 equal to xi minus f of xi by, here we are solving the problem, f of x is equal to e power x minus 3x, and here we have mentioned that root lies between 0 and 1. So if it is not mentioned, we have to calculate the initial roots. After that, I am finding the first approximation x0 equal to average of the two roots, 0 and 1. 0 plus 1 by 2, that is 0.5. Then we are applying the Newton-Raphson method formula. This is the formula, xi plus 1 equal to xi minus f of xi by f dash of xi, and here I equal to 1 to so on. So by varying the value of I, we find the roots. So first, when I equal to 1, x1 equal to x0 minus f of x0 by f dash of x0. Here what do we have? F of x is equal to e power x minus 3x. Then we'll find f dash of x is equal to e power x minus 3 into 1. Derivative of x is 1. So e power x minus 3. So this will be x0 is how much? 0.5 minus f of 0.5 by f dash of 0.5. If we solve this, we get the value as 0.61006. Next, I equal to 2, x2 equal to x1 minus f of x1 by f dash of x1. That equal to, when I substitute the values, I get the answer as 0.618996. For I equal to 3, x3 equal to x2 minus f of x2 by f dash of x2. That equal to 0.619061. So here in this Newton-Raphson method, after the decimal, consider at least up till 5 decimals. x4 equal to x3 minus f of x3 by f dash of x3. 0.619061. If we observe, the third approximation and the fourth approximations are approximately equal up till 5 decimal places. Since we conclude here, x3 and x4 approximations are equal, therefore approximated a root of f of x is equal to 0 is 0.619061. So this is the process of Newton-Raphson method. So here in this video we have discussed two methods, that is a bisection method. This is the process of bisection method, and then we have seen the Newton-Raphson method. So this is about the Newton-Raphson method. So one more topic we'll discuss here, that is the interpolation. I'll just give a short description about this interpolation. So what is interpolation? Why do we use the concept of interpolation? For example, if I have a table of values x and y, x is 0, 1, 2, and if I have y 0, 1, 4, can you just tell us what is the value of 3? By seeing the values of y, we can estimate the value of 3. If you observe, this function will be, mostly it will be y equal to x square. 0 square 1, 1 square 1, 2 square 4, this will be 9. If we know the function of x, if we know the functional value of the table, then we can find the value of any value in the table. But if I don't know any idea about the functional value, then how can I find the value of 3? So finding out such type of problems or solving such type of problems is called, the concept is called as interpolation. What it's called? It's called as interpolation. Here in interpolation we have two methods: Newton's forward interpolation and Newton's backward interpolation. So when we use Newton's forward interpolation is whenever our required value is in at the starting of the table, then we use the concept called as Newton's forward interpolation. Or if the required value is at the end of the table, we use the concept called as Newton's backward interpolation. So this is about the Newton's forward interpolation and Newton's backward interpolation. So when the function is not known explicitly, we use the concept called as interpolation. And if your required value is at the starting of the table, we use the formula called as Newton's forward interpolation formula. And if the value is at the end of the table, we use the formula Newton's backward interpolation formula. Hope this video will be helpful for your exams. Thank you everyone.
Like, share and subscribe. Hit the bell icon for more updates.